This is 7.2 part 2, and we're starting off under objective number 2 using the fundamental identities. So the first video I stopped off right here, and this question is asking you to use a definition or the identities to find the exact value of the remaining 5 trigonometric functions. So we have a choice. What I'll do for you is I will use the quotient identities and reciprocal identities for this one, but once again, you can actually solve this question using the same information we did when I did the last example. So the directions say to use the definition or identities to find the exact value of each of the remaining 5 trigonometric functions of the acute angle, and cosine theta is given to equal 1/2. So cosine, by definition, is adjacent over hypotenuse. Remember SOHCAHTOA. Okay. All right. Since I know that, therefore I know a couple things. I know that my adjacent side is equal to 1, and my hypotenuse has to be 2. And also I know that I am doing right triangle trigonometry. So with that being said, I'm going to go ahead and put theta here, and I'm going to label my sides. So the opposite side from theta is opposite, the adjacent side to theta is adjacent, and then the hypotenuse is the side across from the right angle. So I know the adjacent side is 1, and I know the hypotenuse is 2. So I have to find the opposite side. And to do that, I'm going to have to use Pythagorean theorem. So a squared plus b squared equals c squared. So if I plug this information in, I get 1 squared plus, I'm going to call b the opposite side, so I'm just going to put OPP here and square it, and then c is my hypotenuse, so I'm going to take that and square it. So I get 1 plus the opposite side squared equals 4. So if I get opposite side by itself, I get opposite side squared equals 3, so the opposite side equals the square root of 3. And once again, I'm going to only accept the positive 3 because we actually have two answers, plus square root of 3 and minus square root of 3. So now I have all the information, and I'm going to go ahead and write out that the opposite side is square root of 3. Okay, step 2 is to find the 5 remaining trig functions. Okay, so we know cosine. I'm just going to go ahead and write it out again for us. So if I want to do its reciprocal function, the reciprocal function of cosine is secant. And if I use a definition, secant theta is equal to 1 over cosine theta. So if I put this in here, cosine theta is equal to 1/2. I have 1 over 1/2. So to make this correct, I have to take the denominator and flip it over because we have a complex fraction. And I get 2 over 1, or just 2. So now I have the reciprocal function secant. So one of the 5 remaining is done. The other thing you could have done is just flip over 1 over 2 to get 2 over 1, because remember, the reciprocal function is secant. I was just using the identities because we just covered them. Alright, so let's deal with sine. We don't have that value yet, but I know that sine is opposite over hypotenuse. So the opposite side in this case is square root of 3 over the hypotenuse, which is 2. So now I have sine's value. So I have cosine, secant, and sine. So the reciprocal function of sine is cosecant. And if I use the identity, I know that cosecant theta is 1 over sine theta. My other option, by the way, is to use definitions and just flip over the square root of 3 over 2 to get 2 over the square root of 3. But if I use the reciprocal, I get 1 over the square root of 3 over 2. So once again, this is a complex fraction, so I have to take the reciprocal of the denominator to get 2 over radical 3. And I'm not done because I need to use and rationalize the denominator. So I'm going to multiply by square root of 3 over square root of 3. And my answer is going to be 2 radical 3 over 3. And that's my answer for that one. So now I have one more left to get, which is tangent and cotangent. So tangent is opposite over adjacent. So opposite, remember, is the square root of 3 over the adjacent, which is 1. And so that's just the square root of 3. So the reciprocal of tangent is going to be cotangent. And cotangent, by using the identities, is 1 over tangent. So 1 over tangent is 1 over square root of 3 over 1, or just 1 over radical 3. Remember, I have to rationalize that. So my answer is going to be square root of 3 over 3. And that's all of the remaining trig functions. So I have cosine, secant, sine, cosecant, tangent, and the reciprocal cotangent. So those are my answers to this question. And like I said, you have a choice. You can use identities or you can use definition to find the remaining trig functions. There's a couple more fundamental identities that need to be memorized, and it's the Pythagorean identity. So this is not the Pythagorean theorem, it's Pythagorean identity. So the first one of the bunch, and there are 3 of them, is sine squared plus cosine squared equals 1. Memorize this. Okay? The other 2 you can get if you divide everything by sine squared and then divide everything by cosine squared. So you have a choice, like if you can remember to do these steps I'm going to show you, that's fine. Or your other option is to memorize all 3. So to get the second one, what I'm going to do is divide everything by sine squared. So if I divide everything, sorry about that, by sine squared, I get sine squared theta over sine squared theta plus cosine squared theta over sine squared theta, and it equals 1 over sine squared theta. So once again, all I did was divide everything by sine squared theta. Now what I'm going to do is simplify. So sine squared theta over sine squared theta is equal to 1. And by definition, cotangent theta, if I look at the identity, is cosine over sine. So since I know that, I can write this out as cotangent squared theta because I have cosine squared over sine squared. And I also know the identity that 1 over sine is equal to cosecant theta. So I can rewrite 1 over sine squared as cosecant squared theta. This is the second Pythagorean identity. Okay, so now we have the first one, which is sine squared theta plus cosine squared theta. Now we have the second one, which is 1 plus cotangent squared theta equals cosecant squared theta. And we're going to go get the third one. So to get the third one, what I'm going to do is divide everything by cosine squared theta this time around. So I take the original, sine squared theta plus cosine squared theta equals 1, and I'm going to divide everything by cosine squared theta. And then I will simplify by using the identities. So we know that sine squared theta, the identity says it can be written, and let me fix that, tangent squared. The identity is tangent theta, and it equals sine over cosine. That's what I'm trying to get at. And I also know that 1 over cosine by the identity is equivalent to secant theta. So since I know these two things, I can simplify. So sine squared theta over cosine squared theta is tangent squared theta, plus cosine squared theta over cosine squared theta is 1, and 1 over cosine squared theta is secant squared theta. So now I have the third Pythagorean identity. So once again, the first one is sine squared theta plus cosine squared theta equals 1. The second one now is 1 plus cotangent squared theta equals cosecant squared theta. And the third one is tangent squared theta plus 1 equals secant squared theta. So once again, you have a choice. You can memorize all three and not worrying about dividing things and knowing. You have to know the identities anyways, but if you memorize them, you won't have to use them. Or what you can do is divide everything by sine squared theta to come up with the second one, and then divide everything by cosine squared theta and come up with the third one. Once again, if you do that, you're going to have to know the identities. All right, so here's the table of identities that you're going to encounter on the first test. And by the way, I'm going to mention it now. It'll also be on Canvas too, but there will be no calculators on the first test. You do need to memorize these. You will have to write them out. That'll be part of your first test. So all the ones that we just went over, tangent theta equals sine over cosine, cotangent theta equals cosine over sine, cosecant theta, which is a reciprocal identity, equals 1 over sine, secant, which is a reciprocal identity, equals 1 over cosine, and cotangent, which is a reciprocal identity, is 1 over tangent. And the Pythagorean identity is sine squared theta plus cosine squared theta equals 1, tangent squared theta plus 1 equals secant squared theta, and cotangent squared theta plus 1 equals cosecant squared theta. So you have to know all these identities. And the reason why they're called fundamental is because we need them to be able to do chapter 8 at all. Okay, so these are very important. All right, so let's check them out because there's a section in your homework that asks you to write things out. So this is going to require you to use these identities and to recognize them. So if I look at part A, tangent of 20 degrees equals sine of 20 degrees over cosine of 20 degrees. So this part looks complicated, and I know, because we just went over them, that tangent theta is equal to sine theta over cosine theta. This time around, theta is 20 degrees. So what I can do is rewrite sine 20 degrees over cosine 20 degrees as just tangent of 20 degrees. So all I did was I replaced sine over cosine with tangent. So now you just subtract and you get 0, because tangent of 20 degrees minus tangent of 20 degrees is 0. So now let's look at B. I look at this and it looks a little bit complicated because it says sine squared equals sine squared of pi over 12 plus secant squared of pi over 12. What am I supposed to do with this, right? So I have this 1 over secant squared of pi over 12. The reciprocal identity of secant we know is cosine. Okay, so if I have 1 over secant, that's equivalent to just cosine. Okay, being that said, if I have 1 over secant squared, then I can substitute this in for cosine squared. And theta, in this case, is pi over 12. So now I have sine squared of pi over 12 plus cosine squared of pi over 12. And I know with the Pythagorean identity that sine squared theta plus cosine squared theta equals 1. So theta in this case is pi over 12. So sine squared of pi over 12 plus cosine squared of pi over 12 equals 1. So that's how I simplify this down. I had to use 2 of the identities to get me down to just the value of 1. Okay. Objective 3 is finding the values of the remaining trig functions given sine theta, where theta is acute. So once again, this is kind of like the last one we did. It says sine theta equals 1 over 3, and theta is an acute angle. Find the exact value of each of the remaining 5 trig functions. Because you guys aren't broken up in groups, I'm going to work this out for you. But what you might want to do is try to work this out on your own by pausing me, and then when you're ready, click play again and see if you get the same answers. So first of all, I know that sine is opposite over hypotenuse by definition. So that means that 1 equals my opposite side and 3 equals the hypotenuse. Because the other trig functions require to know it's the adjacent side, I'm going to go ahead and draw myself a triangle so that way I can figure out what the adjacent side is first, and then I'm going to go after those trig functions. So I'm going to put theta in the lower right corner. By the way, you can put it in the top if you really want to, but make sure that you are writing out what the sides are. So the opposite side is O, that's across from the angle. Remember that equals 1. The hypotenuse is 3, and that's the side across from the right angle, and the adjacent side, I don't know that yet. So what I'm going to do first is use Pythagorean theorem. A squared plus b squared equals c squared, where c is the hypotenuse. So the opposite side is 1, plus I don't know what the adjacent side is, so I'm going to let that represent as a, and I know the hypotenuse is 3. So 1 squared is 1, plus a squared equals 9, a squared equals 8, a equals the square root of 8. You can reduce this down to 2 radical 2, so I'm going to go ahead and do that. So I'm going to write out what I know. Opposite equals 1, hypotenuse equals 3, adjacent equals 2 radical 2. Now, I have a choice with step 2 to find the 5 remaining trig functions. I can either use the identities or the definition. In this thing, I think it's actually easier to use the definitions, but it's up to you. So I'm going to go with sine first because we already know sine. Sine was given to us as 1/3. So the reciprocal of sine is cosecant. So all I do is flip over the 1/3 to get 3 over 1, or just 3. So now I have 2 of them done. Cosine is defined as adjacent over hypotenuse. Remember, I'm using SOHCAHTOA. So adjacent side is 2 radical 2 over the hypotenuse, which is 3, and I can't reduce that down, so I'm going to go ahead and do that. The reciprocal function of cosine is secant. So I'm going to flip this over to get 3 over 2 radical 2. Now to rationalize this, I'm going to just use the radical 2 portion of it. So I get 3 radical 2 in the numerator, and I get 2 from here. So let me highlight that. And then I'm multiplying square root of 2 times square root of 2. Square root of 2 times square root of 2 is just 2. So I have 3 radical 2 over 4, and I can't reduce this down, so this is the answer. Okay, and finally have tangent and cotangent to do. So tangent by definition is opposite over adjacent. So the opposite side, remember, is 1, and the adjacent side is 2 radical 2. This is going to require us to do rationalizing the denominator. So I'm going to multiply by radical 2 over radical 2. So 1 times radical 2 is just radical 2. And once again, I have this 2 hanging out here times radical 2 times radical 2, which is just 2. So I get radical 2 over 4, and I can't simplify this down because the 2 is underneath the radical and the 4 is not. And finally, the reciprocal function of tangent is cotangent. So all I have to do is flip over 1 over 2 radical 2, so I get 2 radical 2 over 1, or just 2 radical 2. So those are the 5 remaining trig functions. So hopefully you got them right, and that will end section 7.2. Congrats! Keep up the good work, and go ahead and watch 7.3 part 1.